Good evening, everyone. We will be starting in 5 minutes. Guys, I think we can start now.
Good evening, everyone. We are the AIML team, and today we'll start with the introductory part of ML. Uh, Next slide, please. We are the Developer Student Club. As many of you have attended, most of you must have attended our introductory session. So today is our first ML introduction session, and hope that you all will enjoy this. Next, please. So what is exactly AI or ML? Machine learning is the latest buzzword floating around. It deserves to, as it is one of the most interesting subfields of computer science. So, what does machine learning really mean? Let's try to understand machine learning in layman terms. Consider you are trying to toss a paper to a dustbin. After first attempt, you will realize that you have put too much force in it. After second attempt, you will realize you are closer to the target, but you need to increase your throw angle. What is happening here is basically after every throw, we are learning something and improving the end result. We are programmed to learn from our experience. This implies that the tasks in which machine learning is concerned offers a fundamentally operational definition rather than defining the field in cognitive terms. This follows Alan Turing's proposal in his paper Computing Machinery and Intelligence, in which the question, can machine think, is replaced by the question, can machines do what we can do? Like, what can the machines perform as better as the humans. Within the field of data analytics, machine learning is used to devise complex models and algorithms that lend themselves to prediction. In commercial use, this is also known as predictive analysis. These analytical models allow the researchers, data scientists, engineers, and analysts to produce reliable, repeatable decisions and results, and to uncover hidden insights through the learning from relationships and trends in data. Uh, there are many examples for machine learning. We'll see through it. Next slide, please. So, as I explained earlier, the concept of learning is applied in an ML system. In an ML system, you take the experiences and learn from it, and a model is produced. Uh, we'll see this through some examples. Some of the popular examples of ML are personal assistance, predictions while commuting, video surveillance, social service, email spam, and malware filtering. We'll go through it one by one. So first is virtual personal assistants. Siri, Alexa, Google Now are some of the popular examples of personal assistants. As the name suggests, they assist in finding information when asked over voice. All you need to do is activate them and ask them what is my schedule for today, etc. For answering, your personal assistant looks out for the information, recalls your related queries, or sends a command to other resources like phone apps to collect information. You can even instruct your assistants for certain tasks like set an alarm for 6 a.m., etc. So, as I told you earlier, it learns from its experiences, tries to predict the outcome, and also learns from the outcome. So, if you do not like a particular thing, it also remembers that, and it will not recommend you in the further part. Machine learning is an important part of this personal assistance as they collect and refine the information on basis of your previous involvement with them. Later, this set of data is utilized to render results that are tailored to your preferences. So, if you dislike a particular video on YouTube, it will not recommend it again and again. Rather, if you like a particular set of videos which are related to each other, the next time you open YouTube, you will have the algorithm predicting those kind of videos. So they want to engage you in a particular for a particular time, so that they take your preferences and tailor the app according to those. The second is predictions while commuting. So imagine your life without Google Maps. We all have been using GPS navigation services. While we do that, our current locations and velocities are being saved at a central server for managing traffic. This data is then used to build a map of current traffic. While this helps in preventing traffic and does congestion analysis, the underlying problem is that there are less number of cars that are equipped with GPS. Machine learning in such scenarios helps to estimate the regions where congestion can be found on a basis of daily experiences. Uh, the next one is video surveillance. Imagine a single person monitoring multiple video cameras. Certainly, it is a difficult job and also very boring. Training the computers to do this job makes sense. The video surveillance system nowadays are powered by AI that makes possible to detect the crime before they happen. They track unusual behaviors of people, like standing motionless for a long time, stumbling, or napping on benches, etc. The system can thus give an alert to human attendants, which can help to avoid this mishaps. This all While all this is happening, the machine learning is happening at the back end. So you don't while seeing the AI working, you don't see the machine learning algorithms which are behind those working AI. Then there is social media services. Um as I already mentioned, for YouTube, Instagram, these social media accounts work with cannot work without the features provided by ML. So there are these features called as people you may know, face recognition, similar pins. So all these are based on the activities you do, and the ML algorithm learns from this behavior of yours and generates new similar kind of features. Like if you know a particular person and the algorithm tries to connect you with other similar persons who have similar background profile, so that you can connect with them. Then there is email spam and malware filtering. So we all have been using this spam filter from like the start of Gmail. There are a number of spam filtering approaches that email clients use to ascertain that these spam filters are continuously updated. They are powered by machine learning. When the rule-based spam filtering is done, it fails to track the latest trick adopted by the spammers. Like the spam filtering algorithm is also updated as the malware changes. So if a hacker tries to send you malware and spam with some new technology used, the companies which provide us email services such as Google, etc., they also try to update their filtering algorithm. So it is so that we get updates and the mal we are not attacked by the malware. There are about 325,000 malwares that are detected every day, and each piece of code is 90 to 98% similar to its previous version. As I mentioned repeatedly, that the ML algorithm just tries to learn from previous experiences. The bad experiences are also taken into note. They are also considered, and the good experiences are stored in the memory, and the new algorithm is written on basis of that. So let's dive into ML. Now you know what ML does, what is ML. So now let's start with the basics of how to write an ML algorithm. So I'll hand over, and my other teammates will continue.
So good evening, guys. This is Yash Morankar, and we'll continue with the what is ML and all that stuff we are going to learn. So first of all, coming to the tracks of the machine learning, we'll first see which one are the tracks of the machine learning. So first we have two tracks basically. One is supervised learning and one is unsupervised learning. So here the name itself suggests that what supervised learning is. Supervised learning itself says that teach me, and unsupervised learning says that yeah, I'll learn. So this is the difference. And one more thing we have is reinforcement learning with it. Next please. So these are two tracks, supervised and unsupervised learning. So supervised learning consists of classification and regression, and unsupervised learning consists of clustering. So in classification we have various algorithms such as support vectors machines known as SVMs. Then we have discriminant analysis, we have naive Bayes, we have nearest neighbors. And in regression, we have linear regression. Then we have SVR, GPR. Then we have ensemble methods. Then we have decision trees and neural networks. And in clustering, we have K-means clustering, K-mendroids clustering, fuzzy, and C-means. Then hierarchical, and then we have Gaussian mixtures, neural networks, and hidden Markov model. So next slide. And then we have reinforcement learning, which is one of the most emerging fields nowadays. So in reinforcement learning, we have real-time decision making, we have robo navigation, we have learning tasks, skill acquisition, and gaming AI too. And also there are various applications of machine learning which are listed here. Like in dimensionality reduction, we have big data visualization, feature elicitation, structure discovery, and all. And in clustering, we have recommender systems, which Anga told previously. Then we have targeted marketing, customer segmentation. Then we have in supervised learning, we have classification, which helps in identify the frauds. And then we have image classification, we have diagnosis in medical field like cancer detection, and we have diabetes detection too, very much famous. These are very much famous examples of these. And then we have in regression, we have weather forecasting, which is also one of the very famous and very well-known used example. And then we have market forecasting, means we have stock market prediction too. And yeah, we have many more examples for these two. Next. So first of all, we'll come to supervised learning. What is supervised learning? So we have formal definition here. Supervised learning is the machine learning task of learning a function that maps an input to an output based on example input output pairs. It infers a function from labeled training data consisting a set of training examples. And so this is the formal definition. We'll get to know about this in detail further. So first of all, we'll see the uses of supervised learning. So we have stock market prediction, which was said previously. Then we have image processing, which is one of the most used application of supervised learning. Here we have neural networks used a lot. Then we have disease prediction, and then we have natural language processing. It is also one of the most used application, as we have Google text to speech and many more examples. And yeah, it is the most used algorithm today in the world. Next slide. So here we'll see the details about what supervised learning. So you guys must be knowing that the name only indicates that it is the presence of the supervisor or teacher. Here we have to teach or train the model based on the labeled examples. So consider that if you have a cat example and we are training a machine to classify cat, so we'll having an image of cat, and then we'll have the label that will be given that this image is representing a cat. So this is labeling, and then this machine is provided the set of labeled examples. So such big examples data is provided to the machine, and then the machine fits on the data. The fits word is very important here, because it goes according to according to the data, and then it fits on the data, and then it predicts accordingly. Next. So these are the two main classifications of supervised learning. So first one is the classification and second one is regression. So first we'll see classification. So consider the circles and the plus. So the circles represent cats and the plus represent dogs. So the machine will make a boundary between. So first when we provide the label data to the machine, then the machine will automatically define the boundary, which is you can see by the arrow which is moving there. The machine will automatically determine the boundary, this one red one boundary, and then when the testing data is given to the machine, then it will predict whether it lies on the dog side or cat side, and then it will predict which one is the given testing data. And then further coming to regression is that consider an example such that we are getting marks based on our roll numbers. Means अभी समझ लो कि हमें हमारे रोल नंबर से 2 into मार्क्स मिलने वाले, मतलब अभी किसी का रोल नंबर 1 है, then he will get 2 marks. If anyone's roll number is 2, then he will get 3 marks. Then he will get 4 marks. So such data is plotted here. And when we pass such data, like input is 1, 2, 3, and output is 2, 4, 6. So the machine will fit and machine will determine the equation of the line here, and then it will determine the equation of line, which is given by given in red dots here. So and then predict according to the equation it determined. So this is regression. Next, please. So this is the basic flow of supervised learning. So we'll see this in just a minute, or means ऊपर ही देख लेंगे अपन उसको. So training, पहले तो अपन training वगैरह देखेंगे. So first of all, the raw data is given to the machine, and the features are extracted here, and then it is passed to the model. अभी इधर model मतलब वो जो green वाले डब्बे दिख रहे हैं ना, ऐसा array के नीचे एक array. तो दिस इज द मॉडल, दिस इज द वो उसके फीचर्स है और वो मॉडल में जा रहे हैं और उसके साथ लेबल्स भी जा रहे हैं. तो वो फिट करेगा कि ये इसके लिए ये लेबल है, इसके लिए ये लेबल है, तो अकॉर्डिंगली इट विल फिट ऑन द डेटा. एंड देन वी इवैल्यूएटिंग द मॉडल बेस्ड ऑन द वैलिडेशन एग्जांपल्स. एंड अभी कंसीडर इसको मॉडल को अभी ब्लैक बॉक्स समझ लो, तो उसको अपन मॉडिफाई वगैरह करके सब उसको सिखा देंगे. तो अभी उसके बाद विल गिव द प्रेडिक्शन डेटा. अभी नीचे के साइड में प्रेडिक्शन दिखा है, तो उधर न्यू डेटा will give to the model. Then we have again feature extraction, then we have feature which will be passed to the model, and then model will predict, and based on it will classify the label for it. It will label, actually it will classify in which class it belongs to. So this is the basic overview of supervised learning. Next. So further coming to unsupervised learning, we unsupervised learning का फिर से फॉर्मल डेफिनेशन देख लेते हैं. Unsupervised learning is a type of machine learning that looks for a previously undetected patterns. ये important है, previously undetected patterns in a data set with no pre-existing labels and with minimum human supervision. और the some of the examples of these are anomaly detection. ये तो बहुत यूज होता है, जैसे कि अभी एयरप्लेन में we use anomaly detection कि कोई पार्ट फॉल्टी तो नहीं है. Then we have suggestion maker or we can say it recommender systems. Then we have customer segmentation, means that like certain customers like some A product and certain customers like some B product. So they will be classified accordingly. Like इनको ये पसंद है तो इनका ग्रुप अलग, इनको ये पसंद है तो इनका ग्रुप ऐसा. उनको डेटा मेंटेन करने के लिए they use this. Next, please. So here we'll see other things. So again we have that here there is no teacher for it, as we can on the machine is accordingly restricted to find the similarities, patterns and differences in the data without any prior training of data. So इधर उसको खुद को पैटर्न ढूंढना पड़ता है कि कैसा, मतलब ये ग्रुप इसका, ये ग्रुप इसका, मतलब अपन उसको क्लस्टरिंग बोल सकते हैं कि ये ग्रुप कैट का है, दिस ग्रुप इज ऑफ डॉग एंड दिस ग्रुप इज ऑफ एलिफेंट्स एंड ऑल. So then again there is no teacher here that provides training. The data is not labeled to, and then the machine is here to find the hidden structure here from the unlabeled data. Next, please. So here we can see the basic difference between the supervised learning and the unsupervised learning. With supervised learning में क्या होता है कि the boundary that is shown, that is determined by the machine. The left side वाले is cats and the right side blue वाले is dog. So the machine has made the boundary between the cats and the dogs. And when the sample data is passed to it, then it predicts whether it comes on the left side or it comes on the value comes on the right side. So if it's on left, then it's cat, then it on right, it's dog. So this is how we label and then the boundary is made. But and here in unsupervised learning, we can see we are not providing any labels like these are cats and these are dogs. Automatically the cats and the dogs gets clustered as the mouse is moving. See, this is the cluster of dogs and this is the cluster of cats. So the ये जो गोल है ना, ये मशीन ने, ये बाउंड्रीज है ना, ये ऑटोमेटिकली डिटरमाइन करी है मशीन ने. सो दिस इज द टास्क ऑफ अनसुपरवाइज्ड लर्निंग. नेक्स्ट. And then here we can get a clear approach about what's means. अगर किसी को क्लियर नहीं हो रहा तो इधर क्लियर हो जाएगा. अभी इधर इनपुट डेटा है तो पहले सुपरवाइज लर्निंग में अगर इनपुट डेटा है, then these are apples, so we have given that annotation that these are apples, then we pass it to model fits, and then the नीचे वाला apple question mark वाला, then when we pass this to model, then it goes to the, then it predicts that this is an apple. but अभी unsupervised learning में देख लेते हैं. तो ये इनपुट डेटा इसमें कुछ रैंडम है, तो कोई बनाना है, कोई एप्पल है, कोई ऑरेंज है, तो ये मॉडल को दिए. अभी मॉडल ने खुद क्लासिफाई करे कि पहले चार जो थे वो एप्पल में लिए, वो क्लास 1 हो गया, फिर दूसरे 3 थे वो ऑरेंज, वो क्लास 2 हो गया, और बनाना क्लास 3 हो गया. तो दिस इज द थिंग व्हाट अनसुपरवाइज्ड लर्निंग डज. इट ऑटोमेटिकली क्लासिफाई, इट मेक्स द क्लासेस. So these are the things of supervised and unsupervised. Further coming to reinforcement learning. So reinforcement learning is an area of machine learning concerned with how software agent ought to take actions in environment in order to maximize the notion of cumulative reward. So इधर reward सबसे important word है, reward reinforcement learning में. So इसके maximum uses तो gaming AI we can see that. Then we have autonomous driving too, and then we have autonomous robots. So this is the most developed field of the machine learning now, till now. So next. So this is the basic structure about how the reinforcement learning works. So first of all, the agent is the one who acts on the system or the environment. So when the agent does something action on the environment, so then he gets a positive reward, means he gets a positive or negative reward. भी positive reward मतलब कैसे कि उसको फायदा हुआ, एंड नेगेटिव रिवॉर्ड मतलब कैसे कि उसको थोड़ा नुकसान हुआ या फिर फायदा अच्छा नहीं हुआ, मतलब नुकसान हुआ. तो दिस अकॉर्डिंगली ये फिट करता है कि जिधर फायदा होता है उधर जाता है, जिधर फायदा नहीं होता उधर नहीं जाता है. तो फिर अकॉर्डिंगली एक टेबल रहता है, कंसिडर करो कि अभी तक की एक टेबल है, तो उसको अपडेट करते जाता है कि कैसे ये साइड में जाना है, ये साइड में नहीं जाना है. तो अकॉर्डिंगली इट अपडेट्स इट. एंड सो दिस इन दिस वे इट वर्क्स लाइक पॉजिटिव रिवॉर्ड के साइड में इट goes and negative reward के side में it doesn't go. So this is till now about reinforcement learning. Next. So one of the biggest achievement of reinforcement learning is the Go. Actually, the Google's DeepMind challenge was that it bet the best it bet the best Go player in the world, and yeah, this was done by the reinforcement learning. So this was the AlphaGo challenge, and machine won in this. So this is the power of machine learning and the reinforcement learning. So further, we'll be getting a tour of some machine learning algorithms. So which algorithms are there and what we'll see next. So first of all, we have regression algorithms, correct? So what are regression algorithms actually? The regression algorithms are actually that we'll be seeing in next. So first we'll see that what types of there are in regression algorithms. So first of all, we have ordinary least square regression. Then we have linear regression, logistic regression, stepwise regression, multivariate, adaptive regression splines, and locally estimated scatter plot smoothing. So these are types of regression. Then we have instance-based algorithms. So here we have k nearest neighbors. Then we have learning vector quantization. Then we have self-organizing map. We have locally vectored learning and support vector machines. Then we have regularization algorithms. We have ridge regression, least absolute shrinkage and selection operation, elastic net, and least angle regression. Then we have decision tree algorithms. So decision tree includes the classification and regression tree, C4.5 and C5.0, chi-squared, automatic interaction detection, decision stump, M5, and conditional decision tree. Then we have ensembled algorithms. Then in ensembled we have boosting, bootstrap aggregation, AdaBoost, weighted average, stack generalization. Then we have gradient boosting machines. We have random forest too, which also random forest is one of the well-known algorithms now. Then we have ANN, known as which is an abbreviation for artificial neural networks. So artificial neural networks, basic step is perceptron. Then we have multi-layer perceptron. Then we have backpropagation. We have stochastic gradient descent, SGD. Then we have Hopfield network, and then we have radial basis function, RBFN. Then we have deep learning. So in deep learning, I guess it is now one of the most famous and evolving field nowadays. So in deep learning, we have convolutional neural networks, recurrent neural networks, LSTMs means long short-term memory networks. Then we have deep Boltzmann machines and deep belief networks. So next is the clustering algorithms. So here we have unsupervised learning algorithms. So in clustering algorithms, we have k-means, we have k-medians, we have expectation maximizations, and we have hierarchical classification. And further coming to reinforcement learning, we have DQNs, deep Q networks. So these are the some of the algorithms which are now used, which are till now used in the machine learning and which are developed till now. So further we'll be seeing, and one of them is regression. So hand over to Siddhant.
Okay, so finally, after tons and tons of introduction, we are finally starting with ML. So we'll be starting with regression, which is one of the most important and broadly used machine learning and statistical tool out there. So it allows you to make predictions from data by learning the relation between features of your data and some continuous valued response. They have a broad array of applications, be it object detection, predicting stock markets, or understanding gene regulatory networks. But this was a very formal definition to what regression is. Rather than covering all aspects of regression, we'll focus on few core topics which are widely used in real world to get some state-of-the-art performance. So today we'll look at an example wherein we give the uh, input as the number of hours a student has studied to our model, and it predicts what might be his score. So it predicts the score based on the input, that is number of hours the student has studied. So now if we plot this data, we see on the x-axis we have the hours studied by a particular student, and on y-axis we have the marks he obtained out of 100. So I have this data for something around 500 students. So you guys can see some trend to the plot. So you guys can see some trend to the plot. Can we draw a straight line to it? So if I were to draw a straight line, we could simply draw a line that passes through maximum number of points present there. So that basically is machine learning here. So we humans by visualization and instincts can do this easily, but making machines draw a line like this is fairly challenging task. So let us see how this is done. So first we'll see what the equation of a line actually is. So as everyone knows, y is mx plus c, where we have m as the slope and b as the intercept. So if we plot some arbitrary line, this is how it looks. So I'm just going to change a bit of notations just to make it easy for us in the coming part. We'll replace the slope m with the letter w, which we'll call the weight, and the equation would become y is equal to wx plus b. W still remains the slope of the line, and there is no change to the line. So now we need to find the best possible values for w and b so that our line passes through maximum number of points. So now I have drawn these three lines over here, but they look decently good. But how do I tell which one's better? So here is where we introduce the term loss or error. So for regression tasks, we usually or most commonly use the mean squared error, also called as MSE. MSE is nothing but the difference between the ground truth y and the predicted value y hat, and we just square this term. We square the term only because to penalize large differences in the values, and for the entire training set we sum it over the entire training size, that is say m, and we divide it by 2m just to normalize our values. So this overall function can also be referred to as the cost function, and as you can see, the cost function depends on y and y hat. Y is nothing but the ground truth, but y hat is in turn dependent on w and b. So we can say that the cost function j is dependent on both w and b. So if you plot this data, this would look like some convex function. So having some cost function, can this help us in making the model any better? Or say, how is the cost function useful? So I have plotted some cost function which is similar to the mean square error. So as we know, the cost function is some convex function regarding our weight and bias. So when we initialize initialize our weight and bias, they have some random location where the loss is relatively high. Consider this orange point over here. So we need to move down to the area with the minimum loss, that is the blue region. But how do we get there? So I have an analogy to explain this. This was by Jan LeCun. So suppose you guys are on a foggy mountain. Your vision is completely blocked. You cannot see which direction to move in. But what you do is you take your feet, move it slightly just to find where the slope goes down, and you slowly move in the direction where the slopes points downwards. So after moving after some time, you'll eventually get to the flat land. But how is this analogy helpful here? So when there comes the term of slope, only one thing comes to our mind, that is derivative. So we compute the partial derivative of the loss function or the cost function with respect to the weight. Then we multiply it by a value alpha and subtract it from the weight w. So we are using the partial derivative as a indicator as in which direction to move, and alpha as the step size. Like you could take large leaps or just take some baby steps depending on how fast or slow you need to go. And we repeat this process until we reach some minima. So you can see a visualization here that tells us you start from the top, move slowly, and after some time you come to a optimum solution where you have the error which is at its minimum. So If we fit the line, so this was our initial line. After I do the gradient descent after a couple of times, I find the line is fitting better, but it's still not at its best. So I continue this for some times. The line gets better at fitting the data, and eventually I get a line which seems perfect to me. So I guess that's all for all that you know that you need to know for linear regression. So let's see how this is done practically. Over to you, Jesh.
Yeah. So hello guys, I'm Jay Shelar, and I'll be showing you some live demo about what these guys were explaining from a lot of time. To start with, is my tab visible?
No.
Hello.
Try sharing it again.
Yes, actually, you need to resume the sharing so that it can be. See.
Yeah, I guess it is visible now.
Yes.
Yes.
Yeah, fine. So I'll be just showing you the live demo about what these guys are explaining. To start with, I guess you guys are ready with your laptops to implement something interesting today. So type in Google Colab and click on the first link. So what you'll have to do is you'll have to create a new notebook here. And your new notebook will be created. You can rename it from here. Suppose you'll have to implement linear regression. Just rename it from here. And telling you about Google Colab. What Google Colab actually is, it is a product from Google Research. And what it does is it allows you to execute your Python code through browser. And it is mostly used in machine learning and data analysis because it has support to all scientific libraries like NumPy, Pandas, and also supports like sklearn and TF, like TensorFlow. And speaking technically, it's hosted Jupyter Notebook, in short, that requires literally no setup because when you use Jupyter Notebook in your local machine, you will have to install all the required packages and everything. So to start with, today we'll implement a simple linear regression model, which will predict the scores or marks of student from the number of hours he has studied. All right, then without wasting a lot of time, we'll directly jump into the code. And so what we'll do is we'll import NumPy. What NumPy is, it is a library for Python. What it does is it adds support for large multidimensional arrays, which we generally use in machine learning. And it also has high-level mathematical functions that are already implemented in it to directly use. We can import this NumPy and directly use. To run the cell, you can click on here. You should have a good network to make this work. So yeah, okay. To add a code block below, you can click on this plus code button. All right. So I guess everyone is with me. Tell me if anyone is having some difficulties with Colab or anything. You can just put it in the chat box. So I will know if anyone is stuck anywhere. I guess there is no difficulty. Everyone is with me. So I'll just go forward. Okay, fine. Thank you. So what we'll do is we'll define one array, NumPy array, and in it, what we'll do is we will specify the number of hours a student had studied. What X is the number of hours studied, which is the input to our model, right? So X is also called as independent variable in the model because it is not dependent, and Y, which is the output variable, it is called dependent variable because it is dependent on the input that we are going to pass. So this is the input X that we are going to pass. Suppose someone has studied for 1 hour, someone has studied for 2 hours. Similarly, we can type 3, 4, 5, 6. To randomize, we can type 4 again. We can type 7, 8, 3 again. Then we can jump on to 10 and even 11. All right. So Control Enter, you can press directly to run that specific cell. It is the shortcut. Control Enter. And we'll also specify the output that is expected. Like in any supervised learning approach, what you have to do is you have to pass the input and what is the output. So from that data, our model will learn. Like if someone has studied for 1 hour and what marks he have obtained is specified in that. So if someone has studied for 1 hour, he'll get only 2 marks. Consider like this, okay? Someone has studied for 2 hours, he'll get 4 marks. Someone has studied for 3 hours, and even he has studied for 3 marks, he got only sorry, he has studied for 3 hours, then also he got only 5 marks. मतलब ऐसा होता है कि बच्चे पढ़ते हैं लेकिन मार्क्स ही नहीं मिलते, होता है ऐसे केसेस. We'll consider that also. Someone has studied for suppose 4 hours, he gets 8 marks. Someone has studied for 5, we'll consider it as 10. For 6, we'll take suppose 11. For 4, we'll consider 9 marks. वर्क में ज़्यादा मार्क्स टेक्निक होता है. ठीक है. For someone has studied for 7 hours, we'll consider 14. Okay. Then for 8 hours, we'll take it as 15, suppose. Then for 3 hours, we'll take 6. Sorry. 6. Then for 10, we'll consider 20 marks. And for 11, also we'll consider 20 marks. And run the cell. All right. Add a code block below, and we'll print those. Okay. Print X and print Y. It's quite simple. Control Enter. You will be able to see the 2 input and output arrays. So insert one more code block below, and what we'll do now is we'll import some more libraries that we'll need to visualize our data. I'll tell you what matplotlib is and what Seaborn is. So what matplotlib is that we have imported right now is it's a plotting library for Python, and it is mostly used for visualizing of data. It has GUI toolkits like tkint, Qt, EWX Python, if you guys know, but it is generally used for visualizing the data. For example, we have these numbers. So what we will do is we'll plot that in a graphical manner, so we can analyze that data by just seeing it if it is correct or not. So, and SNS, what SNS is, Seaborn is Python data visualization library like Matplotlib, and it is used for more attractive and informative statistical graphical representation of what data we have. So what we have to do is just we have to set SNS so that it looks amazing. We will see by commenting it. For now, I will comment it, and we will see what difference it makes once we plot just by matplotlib. So what we'll do is we will scatter the data we have away x, y, and we'll run this. So in this way, our data is plotted, right? What we can do is we can you can see that there is no label on the x-axis, no label on the y, no label for the whole graph. It doesn't look quite good. So what we'll do is we will set the size and everything of that size and everything of the plotted data. It's set by, suppose it's at 100. We will set the title for the graph that we have plotted. Suppose unit test 1. Unit test का marks ऐसा consider करेंगे अपन, ठीक है? And we can also specify some font size and everything from here, so it looks better. Also color can be specified. अपन blue करते हैं इधर से. We'll also specify the X and Y labels. One good thing about Google Colab is it gives you suggestions if you don't exactly know the methods of any library. So when you put in a bracket to a method, you will see what are the parameters. Everything is specified here, so it becomes quite easy and handy to use. All right. So we'll specify the label x-axis soft study, suppose. Okay. And we'll specify the font size. थोड़ा सा बड़ा कर लेंगे इधर. And color अपन कर देते हैं, क्या करेंगे? Green किया, suppose. Okay. Y level भी डाल देंगे अपन. It will be the marks. We'll specify the font size same as above, 15, and the color is green. Okay. So देखो अभी we have our title, we have X and Y labels. The dots are also big now. बहुत ज़्यादा बड़ा हो गया शायद. We'll reduce that size. Okay. Fine. It looks fine now. Is everyone with me? मतलब किसी का कुछ रह गया है? Any doubt regarding something? If you have, you can just put it in the chat box so I'll know. Is there any issue or something like that? Someone is stuck anywhere. Is it like that? Just let us know. I guess no one has any doubt. So we'll move forward, and we will remove this comment, and now see the difference that C1 makes is in the background you can see that grid, so it makes that look more prettier than before. All right, so we are done with the data that we have right now. So what we'll do is we'll add a code block below, and we'll import some more libraries. Linear model, import. We will implement a simple linear regression for now. So what sklearn is? Sklearn is a Python machine learning library which includes all the algorithms implemented in it. So it includes linear regression, logistic regression, support vector machines, decision trees, neighbors, and everything. It includes a lot of algorithms already implemented in it. And what we'll do is we will initialize the model here. So model is equals to linear regression. And once you're done that, I guess, yeah. So we'll add a code block here, and what we'll do now is we will use model.fit. What model.fit does is, here we need to pass our x and y. So we have defined our x and y above कि अपना input और output क्या होने वाला है. So what model.fit does is, it is a kind of black box, you can say, wherein everything that has been explained by Siddhant happens. Like you pass the input, फिर वो line draw करता है, it draws the first initial line, मतलब random initialization जो होता है weights का, that W that is specified by Siddhant. So everything that happens, it is in the black box, you can say. Everything, I mean, जो line, जो gradient descent होता है, जो epochs होते हैं, and जो line perfect जो fit होता है बाद में, वो सब इस model.fit जो अपन ने इधर किया है, वो सब उसमें होता है. So you can say it as a black box, and wherein you pass the input and you get the predicted. It is the training phase of the whole modeling process, you can say. Okay. You can run that cell. So now what we will do is, our model is fit on the training data. Training phase ho gaya hai. So now we will test our model. So we will make the testing data. Usually testing data or training data अपन पहले तैयार करके रखते हैं. मतलब we have our whole data and we split it into training and testing. There is a library in sklearn, I guess. sklearn has a library called model selection, wherein you can directly split the whole data that you have into 25%, 20%, 30-70 ऐसा अपन स्प्लिट कर सकते हैं. ठीक है. तो अभी के लिए अपन मैन्युअली करते हैं सब, बट एज वी गो फर्दर, मतलब अभी जो बाद में सेशंस हो गए, यू गाइस विल बिकम हैंडी विद कोलैब एंड एवरीथिंग. सो तब अपन ये सब फंक्शंस वगैरह लाइब्रेरीज का यूज़ करेंगे. ठीक है. इज देयर एनी प्रॉब्लम? सबका मॉडल ट्रेनिंग हो गया है? I guess सबका हो गया है. If you have any doubt, you can unmute yourself. You can put it in the chat box. Yeah, great. So we'll define our testing data. Okay. Similarly to what we have done for the training data, we'll specify who 6 3 4 5 and 8 1. I guess this is enough for us. Now it's enough. And similarly, we will tell the output that is expected first. Okay. So for 2 hours, we will keep 5. For 6, I will specify as 12. For 3, we'll specify it as suppose 5. For 4 we can specify it as 8. For 5 we can specify 11. For 10 we can specify it as 19. Similarly for 8 we can specify it as 16. For 1 hour study, if he gets 3 marks, great. Okay, so I guess we have our testing data ready. Control enter. Okay, then add another code block below. अभी अपन क्या करेंगे? We will predict the output for the specified testing data. अभी जो अपन ऊपर ने टेस्टिंग डेटा बनाया है तो वो अपन अपने मॉडल के प्रेडिक्ट फंक्शन में पास करेंगे और what it will return is an NP array जो which will contain the outputs जो मॉडल ने प्रेडिक्ट किए. ठीक है, फिर अपन बाद में जो एक्सपेक्टेड आउटपुट था और जो प्रेडिक्टेड है वो कंपेयर करेंगे. ठीक है, तो we will do model dot predict. We will pass test. Okay. Yeah, and पेज अपन प्रिंट भी कर लेंगे प्रेडिक्ट को, क्या प्रेडिक्ट वैल्यूज क्या है वो. Okay, so these are the predicted values for the given input. So what we can do is we can visualize this to make it more clear कि अपना मॉडल किस तरह से काम कर रहा है. तो we'll use matplotlib for this. We'll scatter the points that we have. Test, xtest, and y-test. कलर भी स्पेसिफाई करेंगे अपन, समझो रेड. नाउ दिस इज व्हाट वी आर स्पेसिफाइंग हियर इज वी आर स्पेसिफाइंग द डॉट्स जो आप रुको अपन रन करके देखते हैं. व्हाट दिस रेड डॉट्स आर, दीज आर द एक्सपेक्टेड आउटपुट्स. ठीक है, तो ये सब जो है वो एक्सपेक्टेड है जो टेस्टिंग में अपन ने स्पेसिफाई किया है. तो ये इनपुट देने के बाद ये एक्सपेक्टेड है. और नाउ वी विल प्लॉट द प्रेडिक्टेड आउटपुट्स, उसका एक लाइन बनाएंगे अपन. ठीक है, तो व्हाट प्लॉट फंक्शन डज इज इट प्लॉट्स द लाइन ऑफ जॉइनिंग दैट स्पेसिफिक पॉइंट्स. ठीक है, दैट वी हैव प्रेडिक्टेड फ्रॉम आवर मॉडल. तो एक्स टेस्ट और द प्रेडिक्टेड जो अपन ने ऊपर ये देखो इधर तो प्रेडिक्ट में ये सब आए हैं आउटपुट्स प्रेडिक्टेड वैल्यूज, वो अपन इधर सीधा प्लॉट करेंगे. ठीक है, सी दिस इज द लाइन. तो काफ़ी अच्छे से लाइन ड्रॉ किया है अपने मॉडल ने. इट इज़ क्वाइट गुड विथ amazing output. I mean this is quite amazing. Or if you guys want to predict it for single input, like suppose model dot predict किया और we will have to specify suppose 12 hours के लिए स्टडी किए. तो it can also do it for as single ये. So that 22 आ गया. ठीक है, तो ऐसा सिंगल वैल्यू के लिए भी अपन कर सकते हैं. वी चेंज इट, सपोज अपन ने 3 किया तो फॉर सिंगल वैल्यू इट प्रेडिक्ट्स द स्कोर एज 5. तो this was the example and practical demo of simple linear regression. If anyone has any doubt, मतलब वो कितना भी सिली हो, you can ask it in the chat box और unmute करके बोल दो. ठीक है, अगर मैं एक रिवीजन देता हूँ कि मतलब अगर किसी को समझाने होगा, किसी का छोटा होगा. इनिशियली we imported NumPy, then we specified the training data, the number of hours studied and the marks obtained by students. उसके बाद अपन ने प्रिंट किया सिंपली एक्स एंड वाई, और फिर प्लॉट किया अपन ने मैटप्लॉटलिब से स्कैटर करके ये सब जो डेटा है ट्रेनिंग डेटा वो प्लॉट किया अपन ने, ठीक है। उसके बाद लीनियर रिग्रेशन का साइकिट-लेर्न से मॉडल इंपोर्ट किया, और फिर अपन ने एक्स और वाई जो अपने थे वो मॉडल में फिट किए। then we specified our testing data, and then we predicted the outputs, and then we again plotted the expected output with red dots and the line that was the predicted wala thing. Okay, and single value can be passed like this to the model. So this was the whole thing. If you have any doubts, you can ask it in the chat box. ठीक है, अनम्यूट भी कर सकते हो तुम लोग। Is everyone with me? Siddhant, am I audible?
Yes, yes.
Yeah. सब लोग बहुत शांत है, इसलिए मेरे को लगा कि मेरा नेट ही चला गया, तो थोड़ा सा रेस्पॉन्स करो गाइज। नाइस नाइस। So this was a simple linear regression. We have some amazing things planned for you. तो जब भी ये तो बहुत ही simple linear regression वाला मॉडल था। We have some amazing things planned for you in the future. अपन बहुत सारे algorithms सीखेंगे. We will implement different libraries. TensorFlow सीखेंगे. And all this will be Anaga will tell you about our future plans regarding this whole series of AI and ML sessions that we are going to plan. So over to you, Anaga.
The screen
Yeah.
is not visible.
My screen is not visible.
Presentation is not visible.
Yeah, it is visible.
Uh,
It is visible.
It is visible.
Visible.
Okay, fine.
Slide change
So-
नहीं हो रहा ना? अच्छा, okay.
Yeah. I changed it now. So over
Okay.
to you, Anaga. Anaga will tell you about the future sessions that we are going to plan and projects that we'll make. So over to you, Anaga. Thank you. Anaga, are you there?
So I hope yes. So I hope that you have learned something from the previous like more than half an hour. So the future plans we have we are going to drive a little deeper into the actual concepts of machine learning, decision trees, ensemble learning, random forest. So most of these words must be very new to you. Don't worry, we'll try to explain you in detail from the sketch. There is there we will You have learned what is supervised learning and unsupervised learning. So we'll dive deeper into that. We'll learn how to implement supervised and unsupervised learning in more detail. We'll try to execute some examples, real-time applications of ML, which will help you in developing some real-time projects. We'll learn about deep learning, as you must have known about neural networks. We'll try to start from basic neural network to the neural networks which are used today. We will not build a neural network, but we'll try to learn from the basics and just use transfer learning and other examples. Then we'll go through transformers, generative models, autoencoders, GANs, reinforcement learning, and deployment. So at the last, you will be able to deploy your own models and use it on a real time. Then we'll also go through some of the very common projects like IST classifier. So this is a data set of different things. So we'll use this data set to predict and write some algorithms, very common algorithms. There are many
course available online. Also, very different websites provide you with small and basic course which can be understood by anyone. So we'll also try to do the same. We'll go line by line and try to build the algorithms from scratch. There is a California house price prediction data set and um, iris flower loan approval. Then the moon data set which is also there. Then music generation using RNN, sentiment analysis, image captioning, which is also one of very famous applications of ML nowadays. Celebrity face generation and pics to pics. So we will try to do as much as possible from our side. Also, we need some like assistance from you about what we should do further. If anyone has any doubts till now or anything, you can ask. And also that whatever today, whatever the topics were covered today, if you want anything other than that regarding basics, you can also unmute yourself and tell us.
Yeah, guys, if you have any question, you can ask. And the one more thing is, if you want this code or this presentation, we will forward the links regarding that. We will put this on our GitHub, DSC Git account, DSC GitHub. So you can access that from here. We'll specify the links on Discord, so you can follow up from there as well. So if you have any questions, you can ask in the chat box, or you can unmute yourself. Okay.
Feel free to unmute yourself. There is no one here, no teacher. So you can ask it freely. And any language is fine. If you want to ask in Marathi, Hindi.
So I guess किसी को डाउट नहीं है कुछ अभी. So can we move forward? Yeah, fine. There are no doubts. So now Tejas will tell you about something amazing that is going to happen next week. So over to you, Tejas. Yeah.
Okay. Can I share my screen, Jayesh?
Yeah. Sure.
Okay. Just give me a second. Okay, so is my screen visible?
Yeah.
Yes.
Okay, so guys, this is about Pi and AI. This is a series of deep learning.ai meetups independently hosted by community groups. So you must be aware about deep learning.ai. Otherwise, you must be aware about the Coursera. So on Coursera, there is the famous deep learning.ai, which is founded by Andrew Ng. So if you are getting into machine learning or you want to learn machine learning, you must know him, or maybe in few days or few months, you will of course know who is he. He is like the, you can say, a god teacher for all of his courses are very good, and everyone, like most of them, learn from there. And so he has taken Coursera and the deep learning.ai, they have taken an initiative of Pi and AI series, where we all can come together and discuss about new technologies and everything that is coming up in deep learning and machine learning and everything related to AI. So in this session, what happens is that we can call good speakers who are from this domain, or else we can just come together and discuss about new things, which if we do it right now, what we have done is like in DSC, this AI ML series, what we are trying to do is give you everything from basics. So we are aligning it with this Pi and AI series. So all the basics will be taught to you in the DSC series, and then you can join in on like Pi and AI sessions, which will be like once in a month or once in 2 months. And there we can discuss about new technologies and how we can learn about them and how we can get into them. So this first session will be about intro to GANs. So GANs are basically generative adversarial networks. It's cool that if you know about them, but if you don't know about them, it's a great chance to see what it is. And yeah, so for very short and just a thing to show you, there are some demos about GANs. So what GANs is, it just generates images. You can say the full form is generative adversarial network. And there are some wonderful demos which you can go through online. Like there is a sketch to color thing. Like if you give a sketch of a sandal, it will output an image. So it is not basically just coloring it, but it is generating something new, which we will see in the session more about it. Like one more, there it is, like deep fakes and artificial photos. So there is one website known as thispersondoesnotexist.com. So you're looking at a photo which is like which looks real, but this is not a real person. If you refresh, there will be another person. This one is also not real. So these are the images generated by GANs, and we will see how they do it and how we can learn about them. Then this is a very cool demo by NVIDIA. So what they have is like this blue color is the water, sea, and this top is the sky. So if we see, it is basically the sea and the sky. So for painting, if I suppose I take a mountain and I want some mountain over here, right? And I'll see what happens. So it is generating one mountain over here. So I want another mountain over here. So it has generated another mountain, and there are so many things around here which you can play with, like buildings, bridges. So suppose we want some bridge across this, or suppose we don't want the ocean, we want snow. Okay, so you can see the mountain is also covered with snow. So how does it do this? Like it is not just coloring based on something. It is having just a sketch, a rough sketch, and it is generating original photos from it. So we will also see about that. And lastly, there's one project that I had created, that is sketch to color. So if you give it the anime sketches, it will output the colorful colored images about it. So you give it a sketch and it outputs a realistic photo or anime like photo. So we are going to go through all of these awesome projects and how they do it, and what's like we can see more about it. And that's it. So the schedule will be like we will have an introduction about Pi and AI, then what is discriminative models, what is generative models, like which you saw right now, classifying between cat and a dog, that is discriminative, and generative means generating something. So like that we'll go through everything and see that how you can get into it. So it is on the next Saturday, October 17, 11 a.m. to 12 p.m. And yeah, so I'll be telling you about it. And this is the registration link. I'll also share it through WhatsApp and everything. So you can just go there and register yourself. So that's it from my side. I hope you're excited about it, and then we can join there and discuss about it. This will be just about the GANs, and further sessions we can discuss, and we can see what we want to learn. So there are quite new and amazing domains and new models that are coming up. Like you must have heard about GPT-3 or something else. So yeah, we can go there and we can discuss about anything. Yeah, thank you.
Yeah, thanks a lot, Tejas. I urge you all guys to register for this amazing opportunity to learn about GANs and everything. Even if you guys don't know what GANs is, I guess Tejas will tell everything from scratch. So please join the session on 17th of October. Everything regarding the registration and everything will be forwarded soon on your WhatsApp groups or even on Discord. So stay tuned for that.
Also, feel free to post any doubts on the group. Anything you can also message us. Even the smallest doubt, we'll try to resolve.
So any more questions to ask from your side?
If you have any questions, you can stay back if you don't want to ask with everyone else.
And also there is a special channel for this on our Discord server, so you can also join Discord and ask all the doubts over there. Yeah, the link is in the chat. So if you're not joined yet, please join it, because all the further conversation and all the resources will be shared over there.
एंड ऑल्सो गाइस तुम डिस्कॉर्ड तो ज्वाइन कर लेते हैं बहुत से लोग, पर दे डोंट रिएक्ट टू द मैसेज इन द रूल्स एंड डोमेन चैनल. If you don't react to the message there, you won't get access to any of the you can't have any conversation. So to get the access, please react to the messages. It would be good for you.
Yeah, so that was all from our side. Thank you all guys for joining on Saturday. Even you're doing whole week lectures, you joined for Saturday. It's great, and I hope you guys enjoyed the session. Thank you so much for joining. And if you guys don't have any doubts, I guess you can leave the meeting now. We are done with the session. Thank you.
Thank you guys.
Hello, am I audible?
Yes.
Siddhan Bhaiya, can you explain gradient descent and forward propagation, backward propagation in depth? Like what's really happening in the neural network when we are doing propagations? And also in gradient descent, why we are just going at the very, the smallest value of that curve? What is happening in the state? Like I was doing the same work, but like I can't visualize it at that time. So if you help it.
Okay. So मतलब फॉरवर्ड प्रोपगेशन और बैकवर्ड प्रोपगेशन का तो न्यूरल नेटवर्क वाले सेशन में एक्सप्लेन करेंगे. ग्रेडियंट डिसेंट के लिए जश पिछले वाला स्लाइड. हाँ बस यही.
हाँ ये कॉस्ट फंक्शन ठीक है, कॉस्ट फंक्शन समझा है. लाइक ग्रेडियंट डिसेंट में फिर हाँ ठीक है पता.
नेक्स्ट स्लाइड ये ना. हाँ
नेक्स्ट
स्लाइड के तो ग्राफ वाला. हाँ तो अभी मतलब देख कैसा है. अरे ग्रीन ग्राफ वाला.
अच्छा आधीची स्लाइड
एक काम कर. हाँ अच्छा आधीची
मीच प्रेजेंट करतो था.
हाँ यहाँ पे अपन ना वो जो ग्राफ का जो अपना लोवेस्ट मोस्ट पॉइंट लेते हैं वो लेते हैं, वहां पे जा रहे हैं अपन. तो ऐसा क्यों कर रहे हैं? मतलब वो लोवेस्ट पॉइंट पे अपने को एक्यूरेसी क्यों मिल रही है 100%?
Okay.
अब देख मतलब अभी ये जो फंक्शन है ना, वो तो समझा ना किस चीज का फंक्शन. लॉस.
हाँ वो कॉस्ट फंक्शन समझा मुझे.
हाँ ठीक है. फिर अभी मतलब देख कैसा रहता कि तेरे वैल्यूज है सपोज कुछ वेट और बायस के, तूने इनिशियलाइज किए हैं मतलब वो ऊपर किसी रीजन में जहाँ पे लॉस का वैल्यू रिलेटिवली हाई है. तो क्या होता है अगर तुम प्रेडिक्शंस कर रहे हो तो तुम W और B के वही वैल्यू यूज करोगे जहाँ पे लॉस ज़्यादा है. तो जब तुम प्रेडिक्शंस करते हो तो तुम्हारा जो ग्राउंड ट्रूथ है और जो प्रेडिक्टेड वैल्यू आता है उनमें डिफरेंस बहुत ज़्यादा रहता है। तो
हाँ
फिर वही डिफरेंस जो है हम कम करने के लिए इस ग्राफ के मिनिमम पे आते हैं। तो इस पॉइंट पे जो मिनिमम है लॉस का, वो ब्लू रीजन जो है उस पे जो वेट के कॉन्फ़िगरेशंस है वो अगर यूज़ करते हैं तो मतलब प्रेडिक्शंस जो रहते हैं वो ग्राउंड ट्रूथ के मिनिमम दूर रहते हैं, ऐसा रहता है।
वो हाँ हाँ
एकदम।
बोलो भैया।
हाँ, एक मिनट
हाँ
है, मैं एक स्क्रीन शेयर करता हूँ, इससे समझा तो एक बार ट्राई कर। दिख रहा है क्या वाइट वाइट बोर्ड?
हाँ दिख रहा है।
ओके, ठीक है। अभी समझिए कॉस्ट फंक्शन है, ठीक है।
हाँ
अब कॉस्ट फंक्शन बेसिकली है कि इसमें लॉस कितना है वगैरह, राइट। तो
हाँ
मतलब
हाँ
मुझे
पता है।
वैल्यू चाहिए y, लेकिन सच में वैल्यू है y हैट, ठीक है।
बट
तो इसका जो डिफरेंस है वो लॉस है, समझ, एकदम बेसिक डिफरेंस, एक सादा लॉस है। तो इसको हम स्क्वायर वगैरह कुछ नहीं कर रहे, बस ये सादा लॉस है। तो ये ग्राफ है उसका, ठीक है। तो हमें लॉस क्या चाहिए, सबसे कम ना। तो इधर इधर सबसे बॉटम पे हम क्यों जाते हैं, क्योंकि हमें वो सबसे कम लॉस चाहिए, राइट, सबसे कम डिफरेंस।
हाँ
एंड समझ, हमने इधर से स्टार्ट किया। तो वो ग्रेडियंट डिसेंट क्या करता है कि तुझे डेरिवेटिव मालूम है क्या, डी
हाँ
वाई बाई
हाँ
डी एक्स।
हाँ।
हाँ, तो डी वाई बाई डी एक्स अगर ये पॉइंट का निकाला तो क्या मिलता है इधर
तो
का,
वो स्लोप नीचे जा रहा है अपना।
इधर का स्लोप मिलता है, राइट। और ये स्लोप ऐसे
हाँ
ऊपर के डायरेक्शन में दिखता है। तो जो कॉस्ट
हाँ
फंक्शन रहता है ना, सपोज एकदम बेसिक अंडरस्टैंडिंग के लिए समझ, डी वाई बाई डी एक्स लिखा, तो ये ऊपर की डायरेक्शन है, उसको हम माइनस करते हैं। मतलब क्या कि
हाँ
नीचे की डायरेक्शन।
नीचे आ रहा है हाँ।
तो हम इसको बोल रहे हैं कि जिधर स्लोप बढ़ा है ना, जिधर बढ़ रहा है उसके ऑपोजिट डायरेक्शन में आप, राइट।
ओके
तो अब कितना आएगा वो अपने पे डिपेंड है, उसके लिए एक अलग रहता है कि लर्निंग रेट क्या रहती है। तो एक तो इतना आ सकता है, नहीं तो डायरेक्ट इतना आ सकता है, नहीं तो सपोज डायरेक्ट बाउंस भी हो सकता है, राइट। पर उसको
हाँ
डायरेक्शन अभी पता चल गई, तो सपोज एकदम छोटा स्टेप लिया, अब इधर का वो ग्रेडियंट निकालेगा, फिर इसको ऊपर का
हम्म,
मिलेगा, फिर उसके ऑपोजिट की डायरेक्शन है, तो फिर से नीचे आएगा, ऐसे नीचे 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 आते वक्त एक पॉइंट आएगा कि उसको एकदम कम, मतलब इतना ही लॉस हो सकता है, इसके नीचे अभी लॉस नहीं जा सकता।
हाँ
तो ग्रेडियंट डिसेंट का बेसिक
ओके।
फंक्शन ये है कि ग्रेडियंट निकालो और जिधर पॉजिटिव ग्रेडियंट है उसके ऑपोजिट में जाते रहो।
तो भैया लाइक अपन
हम्म,
अगर एक सबसे ना सिंपल वाला न्यूरल नेटवर्क देखते हैं अपन, तो उसमें मान लेते हैं अपन एक लास्ट एल है। एल यानी नंबर ऑफ लेयर्स होते हैं ना। तो एक
हम्म,
लास्ट लेयर्स में कुछ वैल्यूज मिलते हैं ना। तो फिर
हम्म,
वो वैल्यूज में बहुत डिफरेंस होता है, और अपना एक एक्यूरेसी में से उस पूरे लेयर में से एक एक जो होता है, जो उसका एक नेटवर्क होता है, एक पॉइंट होता है, उसकी एक वैल्यू होती है, वो अपना
हम्म।
आंसर्स होता है। बट उसमें ना कुछ मीन निकालते हैं। तो वही है क्या जो उसका लॉसेस है, जो एरर्स है वो कम कर रहे, वही हो
हाँ,
रहा है
मतलब
क्या यहाँ
मैंने
पे?
ये जो बेसिकली बताया ना तुझे कि वाई
हाँ
हैट माइनस वाई, तो इससे ज्यादा काम नहीं बनता, क्योंकि डायरेक्ट माइनस लेके तू लॉस कैसे निकालेगा। उसमें एक बड़ा फंक्शन
हाँ
होता है जो प्रेजेंटेशन में दिखाया था ना, कि लॉग
हाँ
लेते हैं, लॉग ऑफ वाई वगैरह ऐसा रहता है। तो
हाँ
फिर
हाँ पता है।
वो पूरा एक फंक्शन रहता है, उससे वो लॉस निकालते हैं। तो उससे अच्छा है कि ये फंक्शन आता है। सिर्फ वाई माइनस वाई हैट लिया होता तो कुछ तो भी अलग ही फंक्शन है, कुछ लाइन आता। तो फिर एक फंक्शन है जो निकाला है उन्होंने कि ये लॉस सबसे अच्छा काम करता है। वैसे बहुत सारे रहते हैं, तो ज्यादा करके कॉन्वेक्स मिल जाते हैं अपने को, लेकिन बहुत कॉम्प्लेक्स। ये तो सिर्फ 2D है ना, एक्स एक्सिस और वाई एक्सिस। तो इसमें और
हाँ
थर्ड पैरामीटर हो सकता है कि नंबर ऑफ आवर्स था, तो और कुछ हो सकता है, उसका इंटेलिजेंस, IQ वगैरह। तो ये बहुत 3D 4D 5D ऐसे 100 डायमेंशन, बहुत डायमेंशन में जाता है। तो हमारे विजुअलाइजेशन के लिए हम देख रहे हैं बस ज्यादा 2D में।
हाँ ओके समझा। थैंक यू भैया।
हाँ, ठीक। तो यस।
Hello, Suresh.
बोला बोला.
We can stop recording now, right?
Yeah, stop recording.
हाँ.